Hey, welcome back. So we are going to pick up right where we left off yesterday with the system of equations by matrices, and we're going to jump into systems of equations by graphing. So you may or may not recognize this equation from yesterday. This is the one, just to give you the quick review, we put our coefficients in one matrix, and then we ended up with x, y in the other matrix, our variables, and then in the last one we had our constants, 6 and -6. And if you recall, or even if you don't recall, when we did this, we got an error, basically. We said the calculator said, can't do it, can't find the inverse of that matrix, can't find a solution of that system of equations. So we're going to start by looking a little further at that situation. So in order to graph these and look at them maybe with a little more detail, we're going to need to put them into slope-intercept form. Right now they're in standard form, so we're going to try to get them into slope-intercept form, and we just need to get y right here all by itself. So the first thing we'll do is to, I'll do it over here so you can fully see, 3x plus 2y equals 6. We're going to subtract 3x from both sides. When we subtract 3x from both sides, we end up with 2y equals -3x plus 6. Last thing we'll do is we'll divide both sides by 2, and we'll end up with y equals -3/2 x plus 3, because that's what 6 divided by 2 is. So -3/2 x plus 3. That's this top equation. The second equation we'll do in red, I don't know why, but we'll work that down here. 9x plus 6y equals -6. Same process, try to get y by itself. We'll subtract 9x from both sides, and then bring the answer up over here. It's going to leave me 6y equals -9x minus 6. Divide everything by 6. I'm left with y equals -9/6 x minus 1. And 9/6 reduces down to 3 over 2. Okay, so 9/6 is the same as 3 over 2, because 3 times 3 is 9 and 3 times 2 is 6, so that simplifies. So I'm just going to rewrite this as y equals -3/2 x minus 1. So hopefully there's a light going off and you're going, hey, they have the same slope. And then maybe there's another light going off saying, hey, they have the same slope. That means something. What does it mean? Well, it means that those two lines are parallel. And if you remember back, when we're solving system of equations, back to that catalog store example, we're trying to find out where the lines cross. And if they're parallel lines, where do they cross? That's right, they don't cross. So if we look, if we graph both of those lines, we get two parallel lines. There they are. Okay, this is the y equals -3/2 x plus 3. This is y equals -3/2 x minus 1. They're not going to cross no matter how far we extend the screen. They're parallel lines. That's why the calculator didn't want to give us a solution back here, because there is no solution. So that's maybe one of the reasons why sometimes we graph things to give us an idea, is there going to be a solution? We're going to move ahead and just do a little graphing, and I'm going to try to be really neat and make nice lines so that we can use something with the answer. These equations are in slope-intercept form. Okay? And if we remember, with slope-intercept form, we've got the slope and the intercept. The intercept, when we're graphing, tells us where to begin, and the slope tells us how to move. So as we're working our way through this, we'll start with this one because it's actually a little easier to deal with. We're going to begin here at 1, so there's 1, and we're going to move up 1 and over 2 every single time that we go. So we go up 1, which is right to there, and over 1, 2, which is right there. So when I try to draw a line, I will try to draw a line that passes directly through all of both of those points. I think I've done it. Okay? So there's the first one. Then we go back and we'll do the second one. This time we're going to start at -4. And we're going to go up 3. So that's up 1, up 2, up 3, and over 1. So my second point's going to be right there. Grab hold of a line maker and try to make a line that crosses through those 2 points right there. And it might be something like that. So it's looking like, if I was a guessing man, those two lines cross right at about 2 comma 2, if I was guessing. And whenever we're doing a system of equations, we want to know the answer, so we want to know the coordinates of that point where they intersect. If I make it big enough, it's at 2 comma 2. See if that makes any sense in this context. Half of 2 is 1. 1 plus 1 is 2. So that sort of works. And 3 times 2 is 6. 6 minus 4 is 2. So that works as well. So that's a reasonable answer for this. So that's all we're kind of looking for. If it turns out to be a little more difficult, well, we'll try to deal with it. So just real quick, go through y equals 3x plus 5. Begin at the 5. Remember, we have the positive slope, so we're going up 3. So up 1, 2, 3, that's to there. And over 1. Oops, I didn't need to put that little mark there. Didn't mean to. Let's get rid of it so no one's confused. Got enough points to make a line? Might as well try to make a line. Let's see. It's not bad. Fidget with it a bit. Maybe something like that. Yeah, be close enough for government work. The next one, 2x, negative 2x plus 10. We're going to start up at 10, my intercept. We're going down 2 over 1. Hey, same sort of place. Looking like we'll get an intersection on this one. Let's see. Maybe it's right about there. Looks like maybe about 1 comma 8 if I had graphed these right. If you had graph paper, you'd want to graph them more accurately. I'm sort of doing an approximate, and that's really one of the keys for this form of solving equations. It gives us a rough answer. We get an idea of whether there is an actual answer or not, and we work from there. All right, that was Caleb stopping by. Shout out for Caleb. As I think I was saying, we're looking for an approximate answer when we're doing these. We're trying to find out roughly where they cross, if they cross. If we need real precision, there's other methods that will get us answers. All right, so we've done a couple in slope-intercept form. Now quickly we'll get into some standard form sort of equations. This is standard form. You know, a is something x plus something y equals some number. What we're looking for on these is we're looking for the place where we're looking for the x-intercept and the y-intercept. So where's across the x-axis? Where's across the y-axis? Well, when we're looking for where it crosses the x-axis, that happens when y is 0. So we take our little green block, we cover up y equals 0. 3 times x equals 12, so x equals 4. That's my x-intercept. Grab the green block. The y-intercept happens when x equals 0, so we cover up x. 2 times what equals 12? 2 times what equals 12? Well, y equals 6. There's my y-intercept. Got 2 points. I can make a line, so I will. And my line might look something like that. See if I can't grab hold of it, and there, I can do a better job that way. A little bit that way, something like that. Perfect. So, second one, find the x-intercept. Let's do this one in red, just so we see the difference. The x-intercept, 5 times what equals 20? X equals 4. Okay, so x equals 4. Oh, gosh. I think we're zeroing in on the on where they're going to cross, aren't we? Then we go to find the y-intercept when x is 0. So my y-intercept is 2 times what equals 20? I think it's 10. So my y-intercept's up here at 10. Draw the line. Boom. Might be something like that. Go a little further. So we see that we have the line. Oops, extra line. There's my solution. We always list out what the coordinates are. Looks like about 4 comma, that's a 0. 4 comma 0. So 3 times 4 is 12, plus 2 times 0, still 12. We do the next one. 5 times 4 is 20, plus 2 times 0 is 0. 20 plus 0 is 20, so that is a decent solution. Okay? So the other last case that we'll have is we might have systems where one's in slope-intercept form, one's in standard form. You might be tempted to say, ooh, let's solve this so they're both in slope-intercept form or something else. Let's not do that. Let's just solve the systems the way we know how. Let's get my y-intercept. My y-intercept on this equation, 3 times what equals 24? 8. Then let's grab hold. that little bar, and we'll get our x-intercept. X-intercept, same thing. Still 8. Cooking now. Got a line. Draw it in there-ish. Oh, that's really nice right there. And then we'll do the same thing. We'll just use slope intercept form. We'll begin here, the 4. We'll go up 1 and over 1, 2, 3 to about, looks like there maybe. We'll draw the line. See, I'm excited. And there, something like that. Looks like a good place for it. Next thing we just need to do is tell where they cross. X is equal to about 3, y is equal to about 5. 3, comma 5. We always want to identify where they cross, not just by putting a dot on it, by actually writing the coordinates. It's a good idea to take a minute and check to make sure that you didn't just come up with some crazy number. If x is 3, a third of x, third of 3 is 1. Negative 1 plus 4 is 5. I think. Wait a minute. Did I do something totally wrong? I totally did something wrong. Is this a positive slope or is this a negative slope? I think it's a negative slope. Let's back up on this one. Let's rewind. Let's see if we can rewind. I don't know that I really can, other than just to go and delete a bunch of stuff. So we'll do that, and you'll bear with me for a second. Oh, I'm so embarrassed. So, sometimes mistakes happen. That's really perhaps the point. I didn't do it on purpose, but I'm going to pretend I did. So, third x plus 4 right there. Let's do it in green this time so that we don't make a mistake. Negative slope, we go down 1 and over 1, 2, 3. Okay, the more I think about it, the better it is that I made that mistake, because I checked and my answer wasn't good. So, that's the reason we check, to make sure that we get a good answer. Okay, let's try this on for size. How about 6, comma 2? 6, comma 2. See if that works in this one. Negative 1/3 times 6 plus 4. Third of 6. 6 divided by 3 is 2, so we have negative 2 plus 4. That's 2. That's what we're hoping for. Let's try this one. 3 times 6 plus 3 times 2. Is that 24? 18 plus 6 is 24. Bingo. Okay? So it works. Check your work. Make sure. Negative slopes go downhill, don't they? Okay? All right. So, there we go. Systems by graphing. Should be good. We graph some stuff. We hope we get some intersections, and everything is nice. Oh, there we go. Let's make it a person or something. Thanks for watching. Hope you picked something up. If you have questions, please ask. Thanks.